In this video, we're going to continue to look at how to graph trigonometric functions that have undergone transformations. We're going to look at changes in amplitude, period, phase shift, vertical shift, and midline for each function. We're going to then use those to sketch a graph. Let's start by taking a look at example number 1. For example number 1, we're given the equation y is equal to sine of the quantity 2 theta plus pi. Currently, we need to rewrite this equation so that we're able to find our period as well as our phase shift. Since the 2 is on the inside of our parentheses here, the 2 has been distributed to our phase shift as well as our angle, so we can't get our phase shift from looking at what we're seeing here. So to rewrite this, we need to think about getting just theta and whatever its shift is on the inside of the parentheses. To do this, we would factor a 2 out. So we would say sine of 2 parentheses theta plus, if I'm taking a 2 out, I need to think about what number times 2 would give us 1 pi. That would be 1/2. You can also think about factoring a 2 out as dividing what you have in here by 2. So it's now going to be pi over 2 on the inside of our parentheses. Now that our equation is written in the correct form, we can begin finding our amplitude, period, phase shift, vertical shift, and midline. Our amplitude is based on the number in front of our equation. Given that there is no number here, our amplitude is 1. Our period can be found by doing, in this case, since it's sine, 2 pi, divided by the number in front here that is getting multiplied by theta, which is 2. So our new period is going to be pi. Our phase shift, or our horizontal shift, is coming from inside our parentheses here. Remember, horizontal shifts go the opposite way of what you think they would. So in this case, our graph is shifting negative pi over 2 units, or you can think about it as moving to the left, pi over 2 units. There's no number added at the end, so there is no vertical shift happening. So our midline is still our x-axis, which has the equation y equals 0. Let's go ahead now and start by sketching our graph. I typically like to, make each of these a pi over 4, so this would be pi, 2 pi, negative pi, negative 2, down here would be negative 2 pi. And for our y-axis, we'll go ahead and have it count by 1. So this would be positive 5, this would be negative 5. Now to graph sine, I'm going to start by thinking about what happens at 0. At 0 radians, sine has a value of 0. However, our graph has now been shifted negative pi over 2 units, or pi over 2 units to the left. So 0 will now occur at pi over 2. It would also be 0 once we've gone one whole period, which is pi units, which would be here. Now, if you remember from graphing sine in its most basic form, there's another 0 between where it starts and where the period ends. So there'll be a 0 here as well. So halfway between our zeros, we have our minimum and maximum values. Since our amplitude has not changed, my maximum value is still going to be positive 1. And since it's halfway between, I'm going to go halfway between these 2 points and then up 1. And then my minimum value is halfway between my next 2 points and it's down 1. And so now I have one period of my sine function. I'm going to go ahead and sketch this on the rest of the graph using the same sort of pattern. And there is the sketch of our transformed sine graph. Let's take a look at another example. In this case, there's no parentheses happening, so we don't need to rewrite the form of our equation. We can start identifying our amplitude, period, phase shift, vertical shift, and midline. In this case, our amplitude is 1/2. There's no number getting multiplied by theta, and the period for tangent is pi. There's no phase shift occurring because there's no number inside the parentheses with our angle being subtracted or added. There is a vertical shift of -3 units, which means our midline, which is usually our x-axis, or y equals 0, is going down 3 units. So it's now y equals -3. Let's once again sketch our coordinate plane. When graphing our transformed tangent function, we want to first be able to picture where do the asymptotes occur on a regular tangent function. Since our period has not changed and our graph has not been shifted, those asymptotes will land in the same place. Those asymptotes will occur at -π/2 and +π/2. Our asymptotes are pi units apart, and so all other intervals will have those same, an asymptote at the same interval. So we'll have another asymptote here. And so on. All right, so the next thing we want to do is picture where does our tangent graph normally cross our x-axis. It normally crosses the x-axis right between your two asymptotes, right in the center of them. However, now, since our graph has a vertical shift, that point is going down 3 units. So we'll have a point here. From there, halfway between the point and the asymptote to its right, the graph typically goes up 1 unit. In this case, though, it's only going to go up 1/2 a unit because our amplitude is 1/2. So halfway between here, it's going up 1/2. And to our left, it goes down 1/2. And now we can go ahead and sketch our tangent curve. We can do the same graph in all of our other intervals. And there's a sketch of our transformed tangent graph. Let's take a look at one more example. The first thing that we want to do is inspect and see if our graph is written in the right form. If we look inside our parentheses, we see we have our angle theta, and there's no number in front of it, which means that we don't need to do any factoring, so our equation is good as is. Now we can begin to identify our 5 important values. In this case, our amplitude, the number in front, is going to be 4. The period for cosine is typically 2 pi. And since there's no number, or the number in front of our theta is a 1, 2 pi divided by 1, it keeps our period the same of 2 pi. There is a phase shift coming from the number inside our parentheses here, and since it's negative, we're going to be going in the positive direction, 3 pi over 4 units, or to the right. We do have a vertical shift. It's getting shifted down 1 unit, so -1, which means our new midline is y equals -1. Let's go ahead and start by sketching our x and y axis. Now that we have our x and y axis sketched, I think it's most helpful to draw in your new midline. Our midline is now going to be at y equals -1. Now that we have our midline drawn in, we can kind of forget about this -1 as long as we treat the blue line as though it's our x-axis. So if we pretend that the blue line is the new x-axis, typically cosine on the x-axis would go up 1 unit. However, in this case, it needs to go up 4 units because we have our amplitude of 4. It's also been shifted 3 pi over 4 units to the right. If this is pi, then this would be 1 pi over 4, 2 pi over 4, and 3 pi over 4 right here. So I'm going to shift 3 pi over 4 units, and this is like my new x, or my new value when it would be at 0, and it's going to go up 4 units from there. This same value would occur at the end of our period, so at 2 pi units either direction. So if I were to go 2 pi units this way, on my grid, every 4 boxes is pi. So this is pi, and this would be pi. So there would be another value that would have the same value as this, same y value as this one. So these are our maximum values. halfway between our maximum values, we can find our minimum value. So halfway between them is this line right here. And our minimum value is going to go 4 units below our midline. So 1, 2, 3, 4. So here. Halfway between our maximum and minimum point, if we think about drawing a line just straight like that, is our 0. So right here would be our 0. And here would be our another 0. Now I can go ahead and connect these together. And let's go ahead and finish doing this graph in both directions off the page. So to our maximum here, from 0 to our maximum was 2 units to the right, so it's going to be 2 units on this side, and then 2 more units to our minimum, and so on. And that is our transformed trigonometric function after it's been multiplied by 4 and shifted 3 pi over 4 units to the right and 1 unit down. Hopefully this video has helped you see how you can use the patterns of trigonometric functions to sketch their graphs after undergoing transformations. Thanks for listening.